Welcome everyone to Quarterly 1 Review on Limits. This is a review for your quarterly, your benchmark, your whatever you want to call it, just to make sure that you understand everything involving limits, okay? So this is going to be pretty much almost like a chapter test, okay? A review of everything to do with limits. So I'm going to run through some things you already covered before. May look familiar because it is the same slide we used before, but I'm going to explain it again for those of you guys or gals that may have forgotten. Now, when you're finding limits graphically, we want to find the limit in each one of these cases at 3. What x is approaching always has to deal with the x-axis. So that means we're always going to go right here at 3. So right here is going to be the point that we're finding. Now, 3 from the superscript minus up there, the negative, means I'm coming from negative infinity and I'm going towards here. As I do that, my graph, answer my limit, is always whatever it is on the f of x axis, would 8b4. When I'm finding 3 from the positive superscript, so that's from the positive side, so I'm coming down this graph and I'm approaching that same number. That number happens to be 4. And remember, a limit is what your answer is right before you get to the number, not the actual number itself. Now, because these are both the same, if your limit from the left and the right are exactly the same, your answer is whatever that is, so the answer is 4. Now, f of 3 means what is my actual value here when x equals 3. Okay, that's where our solid dot point, okay, or just a straight line is. So in this case, right here, it's at 4. See, you remember this, right? Good. I should have just cut and pasted my explanation from last time. All right, 2. So now we're approaching 2 from the negative to positive. Okay, so 2 is right here. That's my x value. As I approach it from the negative side right here, coming down, the answer is 2. As I approach it from the positive side, answer is also 2. And because they both approach the same point, they're both approaching point 2. Now here's the difference though. F of 2, what's my actual value at 2? Well, because there's a hole there, there is no value at 2, and the answer is undefined, okay? F of x's can be undefined. You would never put does not exist for that, you would just put undefined. All right, let's look at 3 and 4. Problem 3. As I approach 2 from the negative side, my answer is 1. As I approach 2 from the positive side, my answer is 4. Now, because they don't approach the same point, because these two limits are different from each side, my actual limit here, DNE, does not exist. Okay, it wouldn't be undefined, it would be does not exist. What is my actual value at 2? I look up, I don't have any filled in circles, so the answer is undefined. All right, pretty simple, right? Let's look at the last one. Right here, as I approach 3 from the negative side, my answer is 2. As I approach 3 from the positive side, my answer is 5. They do not approach the same point, so the limit does not exist. Now, f of 3, even though there's a hole here, there is a closed circle here. So that is my f of 3, and the answer would be 5, okay? Now, if you had 2 closed circles, you can't do that, it wouldn't be a function, okay? You can't have 2 values of f of x for 1x, all right? Horizontal line rule. So, that's how to find limits graphically. You should try the first, 14 problems based on this simple graph right here. And now let me go over them. Negative 2 from the negative side. Negative 2 from the negative side. Whoop. Answer is 2. Negative 2 from the positive side. So here's the positive. You're running through this whole graph to get to negative 2. And the answer is negative 3. Now, because these two are not the same, limit is DNE. All right? Limit of 4 from the negative side. So here's 4 right here. So first thing will come from the negative side. It's this side over here. We run through our graph, and our answer is 5. 4 from the positive. So we come through, and our answer is negative 3. All right? And because these 2 points do not touch each other, the limit also does not exist. All right? Should be good with this. Limit of negative 3 from the negative side. So now we're not doing 3, we're doing negative 3 right here, the asymptote. Now, as you approach it from the negative side, our graph is going up, and it keeps on going up, 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 and it's going to go up all the way to, you said it, positive infinity. And if you approach 3 from the negative side as well, it would also be positive infinity. Limit of x approaches 6, all right? So it's not from the negative or positive, it's from both sides. So from the negative side and the positive side, they both approach the same number, and that number is 1. Limit of -3. Okay, as I said before, oh, sorry. The limit -3 from the positive side is also infinity. They're both infinity. But because you can't have a limit, because of the unbounded behavior, you can't have an actual limit that's infinity. The limit doesn't exist. All right, remember, limits can't be infinity, can't be negative infinity. One-sided limits can, two-sided limits can't. The limit as f of x approaches negative infinity. Now that means I'm going this way forever. So as my graph goes this way, all right, what's going on here? Up. We're going to keep on extending up into, you got it, positive infinity. The limit as x approaches positive infinity. So I go through my graph. Now what's this graph doing? It looks like it's leveling off at some type of horizontal asymptote. And it's leveling off at what number? At 0. See, it's kind of like flattening. So the answer there is 0. F of -3. So here's -3. Let's look up. There's just an asymptote there. There is no solid line or solid circle. So because there's only an asymptote at -3, f -3 is undefined. F of 4. All right, from the negative side here, there's a hole, so that's no good. The positive side is a hole, but look at it, right there, filled in circle. Answer would be 2. All right, and f of -2. Hole, not a hole, because that one's where the filled in circle is. That's the one we're going to use, and that is at -3. And that, my friends, because I think you guys are my friends, is how you do graphing. That's pretty easy, right? There's graphing with unbounded behavior. That's graphing with asymptotes, all that stuff. That's merged in a bunch of different lessons in one. Ready? Graphing's the easiest. How to solve limits numerically. This is like one of the first lessons we did here. Really quick, going over it all. Limit of f of x as x approaches c. C is the number that is going to be in our middle. So first thing, you determine what c is. How? You just look to see what c is, and you plop it right there in the middle. Then you take c and you're going to plug it into your equation. Maybe you get an answer. Most likely you won't. That would be your f of c. If you get undefined here, you have to find values slightly less than. So you want to know as x approaches c from the left. So you remember how to find values slightly less than? You subtract a 1,000 from this number. You subtract a 100, and you subtract a 10. Very good. And then what you're going to do is you're going to find the value slightly higher than this value as x approaches c from the right. And you do that by adding 1,000, by adding a 10th, and by adding 100. Right? And then step 4, the last step, if the two answers approach the same number, that is what your limit is. If not, your limit does not exist. So I'm going to take these 3 things, which are actual numbers, and I take them and I plug them into my original equation. Okay? So f of c minus 1,000, c minus 100, c minus 10th. All right? And I get 3 answers here. And then I look to see what these answers are doing. Okay? And I see if f of x is approaching that number. Okay, see if it's approaching, whatever number it's approaching. It could be 3, it could be -3, it could be a fraction, something like that, doesn't matter. Take these 3 numbers, and I plug them into the original equation. And then I see, okay, what is this number approaching? And usually what's happening is you have a number, 0.0, and then just the number at the end of the zeros keeps on moving over. So it gets closer and closer to the whole number you're approaching. If these 2 numbers are the same, that is your answer. If they are approaching different numbers, and not off by like a 10th or a thousandth or a millionth, but you could really see they're going to approach 2 different numbers, limit does not exist, the ending. All right? Hopefully remember that as well. So let's go try some. Now, first step, right here. We're going to use the table to solve this. Yes, I know you can solve it the other way, analytically, but I asked you to solve the table. And you're going to have to plug it into an actual table on the test. Sorry, that's just how things work. All right, so first thing, if I did plug in 3 here, all right, I'm going to plug it in up. Oh, shoot, I get undefined. All right? Yes, I know you could factor and reduce and get your answer there, but we're using our table. So we want to know what is x as it approaches 3 from the left. All right, so what I'm going to do is, when I typed in 3 here, I got undefined, right? So now when 3 approaches from the left, I'm going to subtract 1,000, 2.999, subtract 100, 2.99, and subtract the 10, 2.9. Got it? I am going to, as it approaches 3 from the right, I'm going to add 1,000, add 100, and add a 10. And now you take all these numbers and you plug them in. Now technically, do you have to do them all? No, you can pretty much get away with just 2, and I'll show you how that works. So, say I typed in 2 and 99 hundredths. It doesn't matter what order you type them in. Now the way you would actually type this in your calculator is you got to make sure that you put your numerator in parentheses and you put your denominator in parentheses. Otherwise, your calculator is going to spit out the wrong answer. After doing that and typing this in, which you should have done, you should have got about negative 4.01. Now, right now, you can say, maybe I'm approaching negative 4, maybe not. Let me pick another number, 2.9. All right? Same thing you did here, just without the one extra 9 at the end. You get about negative 4.1. All right? So I could tell personally that this is approaching negative 4. Maybe you want to try another number. If I try this, guess what happens? You get negative 4.001. Okay, so I can see negative 4.1, negative 4.01, negative 4.001. Next one, if I added a 9 on here, there'd be another 0 in the middle. It's approaching negative 4. All right? That's pretty easy. All right, now let's look. Now we're going to type in 3n hundredth in our equation. Same thing, in parentheses on top, in parentheses on bottom. You get about negative 3.99. If I type in 3.1, I'm going to guess 3.9. Negative. There you go. If you typed in this, I don't even have to type in. I know, just from doing this for so many years, this is going to be negative 3,999,000. There you go. See? If you want to type it in, you can. I didn't put it up here because how many times do you need to see me typing things into an equation? What is this approaching? It'll probably be a 3.9 with a little arrow, bar above it. So that would be about negative 4. They're both approaching the same number, and that number is negative 4. All right. Good? Awesome. Take that. Take it in. Absorb it into your brain. All right, problem number 16, 17, 18, 19. Now, the last bunch of problems we're going to do analytically using basic rules. So, what is the limit of a constant as you approach anything? It's just that constant. The answer is 42. No matter what x is approaching here, even if it's infinity, the answer is always going to be 42. Because there's nothing to plug this x into. Problem 17. Anything? Let me sit up straight. I'm getting shorter. Plug your negative 3 in. See if you get an answer. Negative 3 cubed. Negative, negative, negative. 3 negatives is negative. 3 times 3 is 9 times 3 is 27. Negative 27 plus 17. Answer is negative 10. Problem 18. Plug that 7 in. Uh-oh. You get undefined. Oh, I didn't want undefined as an answer, did you? So you know what you have to do? You can make your table if you want, or you could factor. You factor these tons, so you should be good at them. Perfect square. And look at the bottom. If you ever want to know what to factor, like, oh, look at this is probably part of this. Well, it is. X plus 7, x minus 7. These are the same in the numerator and denominator. They cancel out, become a 1 and a 1. X plus 7 over 1 is, the limit of 7 is x approaches 7. The limit of x plus 7 is x approaches 7. Now I take my 7, plug it in. 14 is my answer. You good? All right here. Plug in the 0 right away. 7 times 0 is 0, minus 10 is negative 10. 0 minus 16 is negative 16. Wait a second, we don't have to do anything. Your answer is negative 10 over negative 16. You want to put it in simplest form. A negative over a negative is indeed a positive. 2 goes into both of these. 10 divided by 2 is 5. 16 divided by 2 is 8. So your answer is 5/8. Right? Those are the 4 easy ones. Let's crank it up a level. Uh-oh, these are one-sided limits. So, judging by these things down here, they're probably going to be not good. So, first thing I'm going to do is plug negative 7 in there. If I plug negative 7 in here by itself, all right, I get as an answer 99 over 0. Anything divided by 0 is indeed undefined. Shucks. Well, the negative means I'm approaching from what side? This side over here, right? So as I'm coming here, it's going to be 3 values slightly less than negative 7. So what can you subtract? You can subtract a 100th, and you can subtract a 10. So when I subtract 100, negative 7.01, I plug it into this equation. Now, when you type this in your calculator, 2 things. Here's what you'd have to do. I'm going to just say it out loud. Open parentheses 2 times. Open a second set of parentheses, negative 7.01, close the parentheses, squared. So this actually would be what it looks like in the calculator. Plus 1, close parentheses for your numerator, divided by negative 7.0, open parentheses, negative 7.01 plus 7, close parentheses. And as an answer, you should get negative 9,928. All right, you have to always put negatives in parentheses, and the numerator in parentheses, the denominator in parentheses. All right, because when you square this, it's going to become positive. But if you don't use parentheses there, what happens is your calculator would just think of it as a negative times the positive number squared, making it negative. All right, so that's negative 9,928. If I typed in negative 7.1, I get negative 1,018. If you wanted to go here, your answer would probably be like negative 99,000. But what does it look like we're approaching here from the left-hand side? Negative 1,000, negative 10,000. Doesn't take a rocket scientist. You're approaching negative infinity, all right? Because you're jumping up so much. It's not really close stuff. It's gigantic. All right. Woo. 3 for the positive. First thing you do is you type in 3. 4 divided by 0 is undefined. So we have to make our table. Because this is coming from the positive side, it's coming from where I was just sitting and approaching here. So we're going to throw our 3 right here. And instead of subtracting 100th and a 10th, we're going to add 100 and add a 10th. So when I add 100th here, I type it in my calculator. You just have to do open parentheses, 5 times 3.01 minus 11, close parentheses, divided by, open parentheses, 3.01 minus 3, close parentheses, pops out 405 as an answer. If I typed in 3 to the 10th, going farther away from 3, I get 45 as an answer. If you chose to use 3 to 1,000, a lot of people like the 3 things, which is fine with me, you would get 4,005. So what am I doing? I'm jumping up by almost units of, like units of 10 by times 10 times 10. So it would be approaching positive infinity because I'm getting bigger positively, positive infinity, because I'm getting more gigantic negatively, negative infinity. All right. One-sided limits typically will do that. All right. All right, let's do some trig. You like trig? I don't mind trig. Being a geometry teacher for 15 years, never bothered me. All right, limit. Oh, just plug in the 0. That's pretty easy. Cosine 0. And remember, you should know that one off the top of your head. It's 1. 3 times 1 divided by 16 is negative 3 over 16. If you have to type cosine 0 into your calculator, what is the #1 rule that I try to hammer home every single day in class? Make sure your calculator is in radians. If it's not, if it's still in degrees, you are in big trouble. Go to mode and change it from degrees to radians, or else your answer comes out with some weird number. Ooh. All right, next one. If I typed in 0 here, the bottom would be 0. Okay, so I can't do that. 12, negative 12 times 0 is 0. Anything divided by 0 is undefined. But I can use this little symbol. Remember, we used the squeeze theorem. 1 minus cosine x over x as limit, only as x approaches 0 is 0, okay? The same one, limit as x approaches 0 of sine x over x equals 1, okay? Those are the 2 ones. So 5 times, we could pull out a 5 from here. You're left with 1 minus cosine x over negative 12x. So this is this part right here. So we split them. 5 over negative 12 times 1 minus cos x over x. Now, I treat these as 2 different limit problems. Limit of a constant is just a constant. The limit of this is 0. Anything times 0 is? You guessed it, the answer is 0. All right. You like calculus, don't you? I like calculus. All right, almost there. What can we take out of problem 24? Because if we typed in a 0, oh, just give me the answer. If you put in the 0, you get undefined as an answer. No good. I could factor out x squared from all 3 of these. So when I do that, I pull the x squared out of the numerator. There's 2 ways to do this. This is the one way that the majority of my students over the years like. I don't like doing it this way, but it's fine. Take the x squared out, you're left with negative 98x plus 12. Cancel out those x squareds, leaving you with the limit of 97x plus 12. You type your x equals 0 in. 0 plus 12 is 12. And that's it. Another way to do it is take 2 x's out, leaving you with the 12 here, and 2 of the x's out, leaving you with an x over here. By doing that, you don't really have to skip that step, go right to here. Whatever floats your boat. Number 25, I'm just going to lean back to this one. Negative 7 sine 6x over x. I don't know, I wrote it twice. All right, anyway, you're looking for sine x over x equals 1. Okay, remember I told you the second part of the squeeze theorem? Now, I have to get the denominator needs to match the function inside the trig function. So the function inside the trig function is 6x. How do I get this to match it? I have to multiply the top and bottom by the same number. That number is 6. So if I multiply that by 6 over 6, negative 7 times 6 is negative 42. Sine 6x, because you don't multiply it by the stuff inside. Bottom becomes 6 times x is 6x. Sine 6x over 6x as x approaches 0 equals 1. Negative 42 times 1 is, you got it, negative 42. And that's all just using this formula right here. All right, got a couple more here to do. This is taking longer than I thought. Problem 26, what we're going to use is the limits and limits as you approach from infinity or negative infinity. Now, the way this works is you pick the highest degree term from numerators and denominators. If it's just a polynomial, you just pick the highest degree term, which is 2. 2 is bigger than 1, which is bigger than constant. So I take my negative infinity, and I'm going to plug it into x squared. Okay? Negative number squared is a positive number, so my answer is positive infinity. That's it. Number 27. Pick the L'Hopital's one, remember? Highest degree term on top, x squared. Highest degree term on bottom, x squared. Since they both don't have constants in front, we can cancel stuff out. X squared over x squared reduces to 1. 1 over 1 is 1. All right, so the limit of 1 as x approaches infinity is not infinity. It's a constant, so it is 1. You good? Easy stuff. 28. What do you have to do before you solve anything? Can I go, oh, look at x squared is my highest? No. Distribute. Distribute. Negative 2x squared times 5x is negative 10x cubed. Negative 2x squared times negative 12x squared is a positive x, 24x to the fourth. 15x cubed times x squared is 15x to the fifth. 15x cubed times negative 3x is negative 45x to the fourth. Now I take out my highest degree term here, which is not a 3 but a 4. Not a 4 but a 5. So reduce it to 24x to the fourth over 15x to the negative fifth. 4x is 5x's, take out 4 of these x's, take out 4 down here, leaving me with 1x. 24 over 15. I can take a 3 out. It doesn't really matter that you reduce this though, because when you multiply it divided by infinity, it just goes away anyway. But let's just practice a reducing. 3 divided by 24 is 8. 24 divided by 3 is 8. 15 divided by 3 is 5. Now when I type the negative infinity on the bottom, 5 times negative infinity is negative infinity. 8 divided by negative infinity is what? Negative 0, right? No, it's 0, okay? Any number divided by a negative infinity is 0. Any number divided by positive infinity is also 0. Okay, just 0, not positive nor negative, it's neither. Got it? Awesome. All right, let's go to the last 4 questions of today. 29. What values are the graphs or functions continuous? So obviously these are the graphs, these are the functions. Where is this continuous? Where it's continuous is your answer is always just the x value. So is this unbroken? And this is uninterrupted, so it's continuous from negative infinity to infinity, or x equals all real numbers. All right. 30. Where is the graph for a function continuous? Well, it's continuous everywhere but here at 1. So negative infinity to 1 and 1 to infinity. So x is continuous where x doesn't equal 1. Everywhere but x equals 1. All right, because at 1, you have an asymptote. That's where our graph is broken. Let's look at this function. Oh, remember domain and range? Oh. All right, so this function is continuous everywhere except for where this function is undefined. Where is this function undefined? When anything under the radical is negative. So when 2x plus 16 is positive, which is greater than 0, or equal to 0, okay, so you can't have a negative under a radical, it's undefined. So this number on here has to be greater than or equal to 0. Now you solve like a regular algebraic problem. You subtract 16 by both sides and divide by 2. So anytime x is greater than or equal to negative 8, this graph, this function, is continuous. If you wanted to write it out in that form, it would be from negative 8 to infinity. Oh, actually, I wrote this wrong. Can you figure out why this is written wrong? Which will be fixed by the time we have class. This should be a bracket, because it can also be equal to negative 8, okay? So that's just a weird looking bracket. All right, finally, problem number 13. When is a polygon continuous? Polynomial. See, told you. Taught geometry a long time. Polynomials are always continuous. All real numbers. The little r with a double r sign. Got it? That's it. Boom. There's your quarterly review on limits. Keep calm and know your limits. Good luck on the tests. If you don't need it, you're going to do great.